So what do you think about number 25? Function, not a function? Well, look, if it's a function, each element in the domain should go to one and only one element in the range. Now, this is the domain, this is the range. So the domain, let's just say, what's the domain? 6, 25, and 18. What's the range? Well, the range is just 13 and 12. So what do you think? Function, not a function? The 6 goes where? Only to 13. The 25 goes where? Only to 12. The 18 goes where? Only to 13. Now it turns out the 6 and the 18 both go to 13, but each element here goes to only one element over here. So I'm going to claim that this is a function. Number 29 is interesting. Is it a function or is it not a function? Well, look what happens here. The negative 6 goes to where? 3, and only 3, right? Negative 6 goes only to 3. What about negative 1? It goes only to 3. 2 goes only to 3, and 3 goes only to 3. So every element here, each one of these numbers goes to exactly one number over here. Now, it happens that they all go to the same number, but that's perfectly okay. We just don't want one of these going to more than one of these. The domain here is a collection of first elements, negative 6, negative 1, 2, and 3. And the range, well, there's only one element in the range. This just happens to be 3. Now, it is a function because the negative 6, look at this negative 6. Where does it go? It goes only to 3. It doesn't go to more than 1. It just goes to only one element. The negative 1 goes only to 3. Now, that's true for each one of these. There is not one of these that go to more than one of these, right? Every one of these goes to only one thing, not two. And because each element in the domain goes to exactly one element in the range, I'm going to claim that this relationship is a function. This time in number 31, our relationship is given by a graph. So what's the domain here? The domain is a collection of first elements. So the domain, I'm going to write as this. Here's our domain. What do we have? Well, the first elements in these ordered pairs are what? Negative 5. That looks like a 1, but we're over 1 down 2. So I think we're at negative 5, 1, and positive 5. So I'm going to say we're at negative 5, 1, and 5. What about the range? Well, the range, that's the second element. So where are we? Those are the verticals, right? The outputs. So we're at 3, negative 2, and 3. Yeah, I guess those are both the same height. Okay, so we're at where? We're at 3, negative 2, and we don't need to write that 3 again. Okay, now is this or is this not a function? Well, look, where does the negative 5 go? The negative 5, you can see it right here on the point. When you're at x equals negative 5, the y value is 3, right? So the negative 5 goes only to 3. What about this 1? Well, you go over 1, you go down 2. You don't do anything else. You go over 1, you only go down 2. That's it. All right, so 1 goes only to negative 2. And then what about the 5? Well, you go to the right 5, up 3. You don't do anything else. You don't go to the right 5, up 3, and then up to 7 or down to negative 8. You go over 5, you go up 3. So the 5 goes just to the 3. So every element in the domain goes to exactly one element in the range. So I'm going to claim that this relationship is a function. So here's where we could have a problem. Let's take a look at this point right here. What if we had 2 points like right on a vertical? Like what if I put another point here? Okay, then what do you know about that 5? Well, what would you say about the 5 then? 5 would go where? Well, the 5 could go over 5. It could go up to the 3, right? So the 5 could go to the 3, but also if I go over 5, I go up 3, 4, 5. I could go to 5. Is that 5? Let me count that again. Over 5, up 1, 2, 3, 4, 5, 6. Okay, so 5 could go to 3 or it could go to 6. In that case, it would not be a function. 33, we've got the graph of a straight line. Now, what do we think? Function or not a function? Well, I think it's a function because it passes the vertical line test. If you take any vertical line, move it from left to right, it intercepts that curve in only one point. So it's like pick an x, it goes to only one y. Right, so this is a function. It is a function. And what is the domain? And what is the range? Okay, the domain, that's the set of all possible x values. Now look, this really keeps going on like this. So what does that tell you? If you are on this line, you could keep going this way indefinitely, right? You could keep going all the way to negative infinity. And if you're on the line to the right, you could keep going this way, and the x's are going all the way to infinity. So the domain is this collection here. Now they want us to put this in interval form. So because infinities are not numbers, we're going to have open parentheses here. So let me get rid of that and write it this way. So it's going to go from negative infinity to positive infinity, and I'm writing open parentheses because you can't take on that value. What about the range? Well, what about the verticals? The verticals, you keep going down to negative infinity, and you keep going up to positive infinity. So the range here is also low point, negative infinity, high point, positive infinity.